We'll catch on that we're live. Doop, 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 doop. We're live. All right, let's go tell the world. Gotta grab some of this, copy it, and put it over here. Streaming, game dev, doing software architecture based. And here again. If you're wondering why we're looking at a white sheet of paper, it's because we got some architecture to work out, and then we'll program it. Sunlight's back after 6 straight months of it being cold and miserable and rainy. So my brain is kind of fizzing. I got lots of cool ideas on how to make mech games and submarine games and stuff, all about building. But I do want to make sure that I get this context engine running, because that's what we're building here. This game we're putting together runs on a context engine. And so the basic idea of our game this time is a little bit simpler than some of the other games that use context engines, but it's also a little bit more chaotic. So what we've got is we've got a core context, which will be like a series of events that explains the job that your ship is supposed to do, which might be delivering passengers or patrolling the Delta Quadrant or, taking samples from a black hole or whatever, right? And these are repeatable mission lines. They may fork or they may not, but they're just repeatable mission lines. To spice it up, normally what'll happen is it'll just run in the background, because you got ships, you send them out on the missions, and they automatically just do the job and come back and give you cash. But sometimes things go awry. So these missions are the ones where things go awry. They're the ones where things don't go right. There are variants where things go right, but for the most part, these are missions where there is something going wrong. But what we need to do is add in details, things that complexify it, other contexts. So, for example, if you are scanning a black hole, then it might be all well and good, but then all of a sudden you get a complication, and that complication might be space elves show up. And now that's like a generic term, right? In actuality, the context is filled out. This is a specific space elves show up line of plot. It's like the space elves show up and you get into a fight, or the space elves show up and they use their advanced cloaking devices to harass you, or whatever. It's space elves show up and they have the plague, and now you've got plague-ridden space elves and the black hole. Apparently, there's got to be some connection between these, right? So we've got this complication, and the question is twofold. How do we choose complications, and how do we make complications work out? So basically, what we've got is we've got nuggets. We've got scenes that happen, and all of these are made out of scenes. And the scenes have a number of preconditions and so on and so forth, so they happen in a specific order. Now, this here, these scenes don't have any preconditions. These scenes are the main line plot. Every scene in the main plot can simply lead straight to the next scene in the main plot. So if there is a precondition, well, guess what? The previous event gives you that seed. And so that's what we're starting to talk about. Sorry, I just drank a huge... It was hot out, so I drank a huge thing of black raspberry, naturally flavored, sparkling water. Pardon me if I a little bit. So anyhow, we've got two kinds of things. We've got seeds, and we got constraints. So seeds are simply things that fill constraints. So if we have a constraint of, we must go to the black hole to scan it, right? So we got to go to the black hole to scan the black hole. That's a constraint. Well, then there's a scene where we go to the black hole, and that's a seed. So if there is a constraint of needing to go to a black hole, then there's a seed of we go to a black hole. Get it? seed fills constraints. Seeds are a little bit more interesting than that, though, because they're not contained to a single context. So, for example, space elves show up will have a constraint. And the constraint might be go to a black hole, or it might be go anywhere. And because we've got that constraint, this scene can only fire after a seed. And some seeds, are immediate, and some seeds can happen later. But in essence, this travel to the black hole fills this scene, but it also fills this scene. So we end up with the second context, the space elf context, firing up its second half, right? Now, the problem with this is that these contexts, they have an emotional core. They've got a critical beat, usually the last one or the second to last one, right? These are the emotional elements, and we need to make sure that these happen at the same time. Because if they happen at different times, then you can't get that emotional resonance. You can't really get that to work out. So what we do when we're choosing what kind of complication, we actually look at this scene and we look at this scene and we make sure that they have the same constraints, so that when that scene fires off, we know that we can fire off both of those at the same time because they both have a shared constraint. They don't have to have 100% matching constraints, but they've got to have at least one matching constraint. And then they have to make sure that the other constraints are ready to fire so that we can fire both of those at the same time. So in the end, what we might end up with, that is the wrong eraser. There we are. So just grab this. So our space elves show up would actually end up looking something like this, right? It's a much sparser set of scenes. It's a context where it marches along, but it marches along at a different rate. Now, there's no reason why we can't continue to set this up. Whatever context this scene requires, it may be that there is another mission which has similar constraints. So if this mission requires that, the space elves, the space elves are sick. The space elves are sick and they're searching for a cure. So they show up at a black hole. Well, this might be the cure is found, but there's someone who's trying to prevent it from happening. So the constraint here would be, the seed here would be there's a villain, and the constraint here would be there's a villain, right? And so what we would get is the ability to pop in another complication that has a villain in it. And so we can just choose one randomly that fulfills at least one of the constraints of those beats. So then we'd have like a villain setup where it was like this, right? And we might set it up and we'd have to match up these constraints. We'd have to make sure that the various pieces line up properly across the scenes. And this is a matter of solving for this kind of chaos, right? Except what happens if there is no constraint that matches up and we've got free-floating villainy? We've got like just this random villain thing where, the story is that one of your crewmates' exes is showing up to do, bioterror research or something. But all of the constraints for that, there's nothing filling those constraints. We don't have any connections that'll actually fire off this set. And most specifically, we don't have this one. Not having the rest we can figure out later. But the first one, every time we get it, we need to be sure, okay, well, then that's solved. Now we need this one. Then that's solved. Now we need this one. But here's the thing. We know what constraints we're going to run into before the player even sees a single frame. We just calculate it out in the background, and then we play it out. So when we need to have a constraint and there is no constraint available, well, we just add in another complication, another context. And this context might be the you remind me of my ex. And basically, this is a context where it exists specifically to provide seeds. It has very few constraints, if any. All it does is fire off a tremendous number of seeds. So we look for some of these permissive contexts. So rather than complications, these are enablers. And we look for an enabling context that allows us to get that seed we need. And then we make sure to run that enabling context as fast as we need to in order to be sure that we've got the scene that we actually need to play set up in time. And as you can see, this can create a set of dynamics where we actually include more contexts just to provide seeds for other contexts. And because this is an enabling context, it really doesn't have an emotional beat. It doesn't have to, because it exists specifically to feed into this, and its emotional beat is this context. So the reason that I'm working this out is because I need to make sure that when we program it, we understand what we're doing. I want to be able to create these contexts easily and fluidly. And it is a little bit of it's a little bit of a challenge to work out this without just doodling all the time. So if we come up with constraints and seeds, it's important to know how those are going to end up feeding into each other. One of the ways they feed into each other is a direct lock. Like, we need a villain, so we come up with a constraint feed-in, a mission, a context where we just have a character that we don't like. It introduces a character we don't like. So it's like you have an X complication, and what happens is your X immediately feeds into the villain context on the other side, and congrats, your X is a villain. This kind of direct one-to-one link is not necessarily going to be common, because you may have a different context over here which also requires a character, and there's nothing preventing your X from being both, because they're in different contexts. They're not going to conflict. It's not going to end up that your X is fighting themselves or something, not except for in a very specific rare set of situations. So if this is the space elf system, then maybe the space elves are recruiting someone to help them cure their plague. And so they need a character to act as the doctor to cure their plague. So now what we've got is we've got a context that we need a character to play the doctor, we need a character to play the villain, and we have a context that's providing a character, and it happens to be the same character to both. It might also be different characters. But the question is, what sort of problems does that create when we start to resolve these plots? And the answer is, it doesn't create any if it can be solved at all. Because these contexts all have a critical emotional beat. And any core NPC like this will not die or radically change until their core emotional beat. And you know what? These core emotional beats, the whole point is to do them at the same time. So what we'll get this final scramble where both the elf and the doctor part are trying to figure out what's going on, and you're trying to grab back the elven whatever, and you've got a villain that's trying to blow up a planet or whatever, and it happens to be unfolding at the same time with the same character being important to both of those plots. But I'm not sure how this part actually works, because these scenes are playing at the same time, but what does that mean? So let's go and just take a quick little look, okay? So we got three kinds of contexts. We've got a core context, which is the job that you're trying to do. It might be a more complicated version of the job than usual, but it's the job you're trying to do. Then we've also got a complication, or multiple complications, as many as we'd like. And then we've also got, you know what, I don't like the word enabler. I'm going to go ahead and thesaurus that. Thesaurus enabler. coordinator. Let's call it a coordinator. And we got coordinator events. So those are the three kinds of events that we have, the three kinds of contexts. The core context does have a resolution, typically the second to last scene in the core context. So if we're scanning a black hole, then what we get is a scene where we get back the data and we have to parse it. Or maybe it is a scene where we have to scan and the scanning is really rough. So scan is real rough. So our core scene is us trying to scan. Now, in terms of statistics, this is the least emotionally dense one. All we're really doing is trying to make sure that we have enough statistical points on our ship to do the job. So if we've got to scan it, then we need to have the scanning dishes that we have. So over here, if I hit play, you'll see what I'm talking about, right? So grind. So here's our command systems. No, that's the people. Here's our navigate. Here we are. So we've got this support system where we have all of our shields and science and stuff. You would need to have enough support of the right type to do the scanning of the black hole. And that's the whole point, right? And now that'll be easier or harder depending on how well you've succeeded or how hard you failed on the previous scenes in the core conflict, because these contexts, they have pass-fail. They're not just pass-fail. You can win or you can lose at any given scene. And if you lose at a scene, then you lose points. And if you win at a scene, then you gain points. And that makes future issues more complicated or easier. And that's already built in. That's pretty basic. So, if you don't have the engines to get close to the black hole or whatever, then you're going to have a harder time scanning it. And that's always going to be a balancing act. But this point here is this core conflict, this core context has a conflict at the end where this is it. This is the final thing that you have to accomplish. And after that, you just go home or whatever, right? So the scanning is real tough. Now, if we've got a complication, that'll be something where we also have a core conflict. It might be the last one, it might be the second to last one, but there is a crucial scene, and it just so happens to be compatible with this scene. So this scene might have the requirement, the precondition of close to anomaly. And then the scene before it is obviously you getting close to the anomaly, right? That's just how it works. But over here, this one is also going to be close to anomaly because the space elves need to cure their psychic sickness by going to an anomaly and figuring out, there's something here that blows away the space sickness. So that means that when they get close to the anomaly, when everybody's close to the anomaly, there is something happening with the space sickness. And this can be simply another statistical thing. Like you need to make medical checks. And if you have medical systems aboard or if you have enough support systems aboard, then you can do both at the same time. But how does it actually play out is the question. Because you're getting these challenges, but you're also getting these medical challenges, right? And they might not be med challenges. It depends on how we write it. It might be things like Saboteur arrives and you have to defeat the Saboteur instead. We can write it however we want, but in the end, it definitely boils down to some challenges with certain constraints. Those constraints might be things like certain crew members are missing, certain crew members are busy, or it might be constraints, or it might be something simpler like, these systems don't work anymore, or you need to get these scores good. So what we're looking at here is a situation where the ship is being bombarded by tons and tons of challenges and perhaps having crew and systems disabled as part of the progression. And the challenge here is that both of those happen at the same time. So during the final conflict, you might have, a scanning challenge to scan the black hole, but you might also have an ops challenge to determine whether or not you can command the away team that's trying to undo the sabotage or undo the critical failure on the elf's ship because they're too sick to maintain it or whatever it is. And you have to do both of those at the same time. And they stack up and they resolve quite quickly. And the idea is that you're going to have to do them all. But there is no direct emotional or thematic connection going on. It's not that scanning the black hole has something directly to do with healing the elves or saving the elves. It's just that they're happening at the same time, in the same place, with the same seeds and the same constraints. And I think that's an okay way to think about it in this case. I don't think we need to try and make this thematically balanced or echo properly, because we're going to get a lot of seeds that play in automatically. All we have to do is make sure that there are specific characters. What we have to do is introduce specific characters, and that will make it so that each of these characters plays roles in each of these contexts, and they unroll in the same way. We do have to make sure that the characters don't die before their last scene. So we would have to look ahead, make sure that they don't have any scenes later on. If they do have scenes later on, we can't kill them yet. We need to make sure that they survive. And the coordinators are, of course, for providing the seeds that we might need to make these actually fire. And the coordinators don't have a critical mission. They don't have a critical scene. They just kind of run along until they run out of steam. The only thing is that they probably have a denouement. So rather than having a critical scene, they just wait until the critical scene is over, and then they play their denouement over here. And basically what that'll do is it will allow you to hear feedback about what they think about the character. The problem is that scripting that is tough, because the character could be accepted as a villain. The character could be accepted as a hero. The character could be accepted as anybody. It doesn't have to be a character. It might be something like an old ship. But I think that we can help to resolve those by constraining things to a couple of basic possibilities. Basically, we would have an either-or. And we already have an either-or, right? So we already have a success or failure, and we have different scenes that play depending on whether it's a success or a failure. In the coordinator role, we can also have a success or a failure, as described by previous scenes unrolling. But the idea is that we would be able to... This wouldn't be challenge-based. This wouldn't have any challenges, no significant ones anyway. But instead, it would simply ask you to choose, do they feel good or do they feel bad? Do you let them go on a date or do you need them on duty? All of these sorts of things will allow us to build up a success and fail stat on these challengeless missions. And at the end, well, we can see it going good, we can see it going bad, and it will be our choices that led to that condition. Now, this is going to have to be balanced, because even if, so for example, if someone's ex becomes an evil doctor and tries to kill all of the elves for their space juice, then you can't have a good resolution be that the evil doctor gets back together with your crew member. That wouldn't be a good resolution. That would be a terrible resolution. So when you have that sort of thing, you need to be careful about how you frame it. And the comment would have to be just like a wistful, I can't believe this, but goodbye, something like that, rather than, oh, congrats, you've accepted a new NPC. And what happens is there's a disconnect between this and getting crew members. So whether you pass or fail here, if that person survives, we can run a check to see whether or not they are able to be recruited. If they're in prison, obviously not. If they're dead, obviously not. If they're on the run, probably not. But otherwise, they might show up on your doorstep, and then you'll be like, oh, it's that so-and-so. And, of course, the emotional connection will depend on which way this went. This is the sort of thing I'm thinking of. And you can see how it gets complicated. It gets really ridiculously complicated if we're not careful. And keeping it as easy to use as possible is critical. And I think that the way we're going to do that is that we are going to try doing it with text for a while. So, well, I don't know whether or not I want that. I'm not actually going to do that. What I'm going to do is I'm going to think about things as if they were text, but we're still going to use objects. Just because objects can actually do stuff and text can't. But the idea is we're going to be trying to have objects that can be represented as text strings, very short one-line text strings, and then we will be able to just write those, and we'll just be able to print them out to like spreadsheets and shit. All right. So yeah, where's my mouse? There it is. Currently, our setup is pretty spare. It's pretty broken. Rather than just erasing and continuing with this setup, what we're going to do is we're going to create new objects in a different namespace. So rather than the adventure namespace, we're going to create the context engine namespace. And it should barf. Yeah, see how it's now scene 1. And that's because it's in the same space. So we're going to go ahead and delete that. And over here, we'll go ahead and create a new folder called Context Engine. There we go. Now that should be called Scene. We can pop it open here. And we'll go ahead and namespace Context Engine. And we'll just a collection of, let's make that bigger. A collection of seeds, constraints, and seeds, constraints, challenges. Hold on, let's go ahead and do this first. First, constraints, then a mix of challenges, dialogue, and cinematics, then seeds. I'm trying to determine, I think that we can just do first constraints, then everything else. We don't have to end a scene in order to drop a seed. All we have to do is have that seed exist. We have to remember that seeds can be used immediately, but they can also be used after a delay. There's no difference. So when we're defining this, we're going to need to have some constraints, some challenges, dialogue, cinematic scenes. Those are going to be our own version of a playable. We can't use the playable, as far as I know. It might be interesting to try. Unity actually has a playable. What is this? This shouldn't be there. We're in a different namespace. That's better. Goodbye. Unity actually has a class called playable that's supposed to be descended. So you can descend from playable and create your own playables. But playable in that case is something that has a specific time on the scene. Let's go ahead and just look that up real quick. Playable Unity. The Playables API. Playable API provides a way to create tools, effects, other gameplay mechanisms by organizing and evaluating data sources in a tree-like structure known as a playable graph. Playable graph allows you to mix, blend, and modify multiple data sources and play them through a single output. Playable API supports animation, audio, and scripts. Playable API can interact with the others through scripting. Although the Playables API is currently limited to animation, audio, and scripts, it is a generic API that will eventually be used, blah, blah, blah. So it's not ready yet. Okay, so we won't be using the playables because it's not ready yet. But the playables graph is quite nice. I don't know if you've seen this. Let me go ahead and just... There it is. See it? So the playables graph is a very, very, very nice graph that we can try and hijack. But unfortunately for us, I'm not actually sure whether or not the playables can be. I'm not sure whether the playable graph actually works. Maybe someone knows that and can tell me, but I think that we're just going to go with a custom solution for now. As much as I would like to use a built-in playable system, that would actually be very nice. It's just not ready yet, I don't think. Yeah, there we are. So we're going to have to do our own thing. We're going to go ahead and call it... we could call it a playable. Just put it in a different spot. Now, naming things the same as another existing object is not generally recommended, but we're going to phase out most of the other ones. And this one, I can't think of anything else I'd like to call it. It's a playable. A core nugget of playability does not contain any constraint from playing, but can be set to play simultaneously or not. No, we're not going to bother with that. Does not contain any constraint from playing. But we'll go ahead and just leave it like that for now. So basically what that means, there's no waiting for any reason outside of scene controlled processes. So if we have a stack of playables, like if we have an array of 15 playables, Zargi says, how's the game going? Well, I just spent half an hour working out how the context engine is going to work. It works like this. And now what we're doing is we're programming the context engine. So we got some decent faces, terrible hair. We got some beginner ships that work okay. And now what we're going to do is build stories. And this is a playable for inside of a story. And basically, because there's no constraints from playing, any array of these constraints will simply play through. There might be a constraint of like one has to wait for the previous one to finish. I haven't decided yet. But in essence, there's no outside logic dictating whether or not the next playable element can be played. So these come in contiguous chunks. When we break them up with logic, we break them up into other contiguous chunks. So if we have 3 or 4 of these nodes, these nuggets of playability, they can be wired together via other means, but they themselves just play through individually. Each one just goes zip straight through. Now the idea is this should be an interface, but unfortunately Unity is notoriously bad at interfaces. So we're going to leave it as a mono behavior, at least for now. And I think that we're going to need some public virtual void playable play. Debug.log generic playable, please descend. And there might be others that we need to put in, like we might need an event that fires when a playable has finished, or we might need a thing that keeps tabs on whether the playable is still playing. We're almost certainly going to need that. So we're going to go ahead and have a done playing event. Public Unity event done playing. Now the question is, do we want to have a Unity event that's done playing, or do we want to have a generic Unity event that is a playable? And I think that's a better option. So public class playable event. And that's going to descend from Unity event. I think we need to actually add in the events here. There we go. Unity event playable, like so. And then down here, we can have this be a public static playable event, playable completed, on playable completed. There we go. And that has to have a new playable event due to the way that Unity handles its static variables and serialization. So now what'll happen is we'll just go ahead and say onPlayableCompleted.invoke this. And what that means is that when this event finishes playing, we'll fire off an event that says, hey, I, specifically me, finished playing. And anybody listening to the generic event can say, oh, that's definitely one of the ones that I set off. I'll play the next one. So with that in mind, we can go back over into the scene. And the scene can have a stack of playables. Public playable list. We can call it progression if we wanted to. Let's go ahead and call it progression. Let's call it playables. It's easier to keep track of. This list of playables will play in order from start to finish with no logic interrupting it. Each one will play in turn, waiting for the previous to finish. So in here we're also going to have a play, public void play. And all we're going to do is go through the playables. So we're going to go ahead and say public void. I'll make this protected void play next. Protected int current. Oh, we don't have to do that. Do we have to do that? No, we don't have to do that. So here we're going to go ahead and say playables dot add. Oh, sorry, capital P. Playable dot add dot on add listener play next. And play next is going to take in a last playable previous, like so. And then here what we'll do is we will say int index equals playables dot index of. Now the problem is this can result in infinite loops if there is more than one of these in the playables stack. So if we've got 50 playables and then we've actually only got 10 items that are just repeating, this will end up looping forever. And we don't want that, so what we're going to want to have is actually the playable's last index. Can I get last index? Yeah. So we're going to just get the last index just to avoid infinite loops. Like that. And then what we'll do is index plus plus, and then if playables.count is greater than or equal to index, then we stop. And we return. Otherwise, we play the next one. So we just say playables index.play. Here and stop. We unsign up for the event. Playable.onCompleted. Remove listener. Play next. And debug.log. Completed scene plus name. Easy enough, right? So in short, we should have an engine now for just churning through all of our playables. What we don't have is a concept of seeds and constraints and stuff. That we'll have to build. So the question is, basically the idea is that from the playables, we have a number of things like adding seeds, doing dialogue pop-ups, changing the scene over to a different visual, disabling or enabling crew, or printing to debug. So let's create some of that stuff. That's not how you spell it. That's print to Doug, which I don't really have any interest in doing. Let's call it debug. No, we can't call it debug. We'll call it debug playable. Pop that up. We are inside of the namespace context engine. Doop, 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 doop. And of course, we're descending from a playable. And on our play, override, play. So I think that we're actually going to want to do this a little bit differently. You can see how we play. We want to make sure that... No, we're not going to do that. We're going to do it manually for now. Override void play, and we'll just go ahead. Is it not override void play? Public, sorry. And then what we'll do is we'll say on playable completed.invoke this, but we're also going to just debug log something. So public string debug equals hey. And then we just say console.log. No, it's not console. Debug.log. Debug. There we go. So that's a debug playable. We should be able to see whether or not things are working. We're going to need to create a new scene, I think, for testing purposes. We're also going to need to assign this to an event in the menu so that we can get it. God damn it. There we go. So we're just going to create a box. And then we're going to drop a scene onto the box. Inside of the box, we'll create... These aren't actually boxes. I'm lying. Just call this A. And drop in a playable debug onto A. Take a look. So the playable should be empty, but what I can do is just duplicate this and then drag these in. For now, we'll drag them in one by one. This is not how we'll be doing it in the long run. In the long run, we'll just be typing it in, and the text will automatically generate this stuff. We don't need to actually have it even exist. So we're going to hit play just to check. And now that it's playing, we will play. Well, I'll go over to console first. And it should say, hey, 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 hey. It did not. It didn't say anything. That's interesting. Okay, so let's go in and add in some debugging. Oh! Actually, we'll just say playables 0.play. Let's add in a if playables.count is less than 1, debug.log, warning, no playables in name, return. Gotta actually hook things up, otherwise it won't work. Hey, hey, hey. It only said hey once. It should have said hey 4 times. That's interesting. Let's take a closer look at what is going on there. It might... no, that should be 4 distinct objects. So here we are with debug.log searching for last index of last previous .name. And then what we're going to do is see what it is. Debug.log found at, and then index. Oh, I'm just an idiot. I just had the wrong alligator. Gotta have the right alligator, otherwise you end up eating the wrong thing. Boom, there we are. Hey, 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 hey. All right, so that works fine. So now what we can do is we can start working with the framework to connect these scene chunks together. So that would be the seeds and the constraints. Seeds are playables. So we'll go ahead and namespace context engine. playable. Public static list seed live seeds. So this is more complicated than you might think because we actually don't want to do it like this. Let me just think for a second. We're going to be doing a lot of simulation runs where we detect whether or not the seeds exist and work. And I think the way we're going to do that is we're actually just going to run it in the background. Yep. All right. Let's go ahead and fix this up. So we have a play. We're also going to have a simulate. And the simulate is going to be the same thing, but it's going to be a lot less. Let's go ahead and public virtual void complete. There we are. Sorry. Because we have to be able to simulate these, we're not going to want to play the vast majority of things that need to be played. So, for example, if someone has to say something when we're simulating it, they don't say anything. The only thing we actually have are the logical elements that connect the scenes up, and they'll use simulate instead. There we are. So here we're going to just go ahead and override complete because it's the same both way. Same whether it's simulated or live. Override public void complete. We say base.complete. That's compare tag. There we are. Is that how you do it? I think that's how you do it. It might be super. I can never remember if it's super or base. Maybe it's a super base. C#, super or base. That's Java. It's base. All right, good. So what we're going to be doing is we're going to be adding a seed to the list of seeds. Now the thing is that we're going to need a seed category. So public string category. And we'll go ahead and call this location. And basically, we may make that an enum later, but the idea is that if we add ourselves to the list of live seeds, anything with the same category that's not simply an empty category will be overridden. We are also going to need a public string type. So the difference between these is arrive at anomaly. So let's go ahead and add in what the difference between these is for future reference. Tooltip. Only one thing of a category can exist at a time. Otherwise, tooltip, the specific constraint that gets filled. And we'll go ahead and rename this from type to target constraint or something. There we are. And we may work that out later. I don't think there'll be strings forever. Just leave them that way for now. So what we're going to do is we're going to go through here for int a equals 0, a is less than live seeds dot count dot length dot count a plus plus. And well, this only happens if our location isn't null. If location equals does not equal, if location dot length is greater than 1. Category, my bad, dot length is greater than 1. Do this. Empty string category is not limited. So here we'll go ahead and say if live seeds a dot category equals category, then live seeds dot remove at a minus minus, and then we down here say live seeds dot add a. Nope, this. All right, so that way we simply remove all of the previous constraints are all the previous seeds that need to be removed, and we add ourselves. We'll go ahead and just do a debug.log added constraint to seed list now live seeds dot count long. All right, so that is a seed, and we should be able to add seeds now. So let's give that a shot. Let's replace some of these here with seeds instead of debug playables. So create empty. What happened? Oh, there it is. B. Test A. Test B. And then, of course, add all of those here. Doop. Doop. There are, in fact, faster ways to do this, but there's only 4 of them. There we are. Hit play. Hit play again, but first go over here. Now we should see it count them. There we are. Yeah, okay, I forgot to override playables. I'll just go ahead and delete that. So added arrive at anomaly to seed list. Now 0 long. 0? Oh. All right, so hold on. Let's go ahead and recompile that and try again. I got this really cool idea for a variant on marching cubes, which I think will produce really, really neat looking hulls and armor. I'm kind of still thinking about that in the back of my head. Here we are. Now 1 long, now 2 long, now 2 long, meaning that the first one was removed. Great. And then now 3 long. Logic works. So we've got seeds now, and the idea is that we'll be able to check and see what sort of seeds are available. You know what? We don't need to simulate, do we? My bad. I've made it complicated for no reason. Let's go ahead and simplify it before we do anything dumb. We'll still go ahead and keep the complete. Because that is actually fairly useful, but this will be play. No. Yeah, play is fine. But basically what we need to do is when we're looking for connectivity, we'll actually just look for seeds specifically. We won't just play through all the playables. We will actually search for seeds. This does mean that the seeds cannot be dependent on anything. We can't have a seed that requires you to win or requires you to lose. Just because that would be too much chaos. We wouldn't really be able to guarantee that the missions would unfold correctly. So seeds must be, let's go ahead and write that up here. Seeds must not be conditional. We can't tell whether or not a context will be able to execute if a seed may or may not exist. They must be mandatory and always fire. But of course we're already guaranteed that due to the way that the systems work. The playables work. The players are not conditional. We actually listed that. See? So not a conditional system. So we'll be able to just look for all of the seeds and then play the seeds on their own without anything else. To determine what gets added and what doesn't get added. Moreover, we can just look through the scenes for a constraint that matches our constraint rather than actually needing to go through it. So let's go ahead and add that function. So public list string contained seeds. For each playable P in, that's a B, playable P in playables. If P is seed, then we go ahead and say, I think you can do that in C#. I actually can't remember. So let's go ahead and create a list here. List string seeds equals null, or equals new list string. And then if P is seed, then what we do is we grab all of the seeds. Seeds.add seed P dot. Am I going to have this ability, or do I have to? I think I have to couch it twice. That's no problem. Constraint. And then we can return seeds. We're going to also want to debug.log all of those seeds. So we'll just go ahead and put that in here. Debug.log this name plus contains seed plus this. Now this log is not going to last long. We just need to make sure things work. And we'll make this another thing what we can call via a menu. There we go. So we'll just scroll in and out here. Now this contains two seeds that overwrite each other. That normally isn't going to happen. We might have like a constraint tester that makes sure it doesn't happen, but it's okay. We're not too concerned right now. So let's go ahead and test the seed contents. There we are. Perfect. And if we were to mix in some of the other tests that weren't seeds like this, we should see that it now contains 3 seeds and 2 things that aren't seeds, and it shouldn't crash. Hooray! All right, perfect. All right, so that may have seemed boring, and it is. Software architecture is 90% boring because it's all in your head. If you're just watching it, you're probably like, oh, great, he's programming basic string parsing. Brilliant, what a guy. But if you get your fundamental architecture right, your game kind of comes together. And if you get it wrong, it kind of never does, and you won't be able to do anything. And I find that most people on Patreon who are making indie games and having a really hard time with it, they're often people who got their software architecture wrong. Their game architecture, it does not actually support their game. They just programmed it how it felt like it should be programmed, and now they're kind of stuck in a trap of their own making. And I'd like to avoid that. So we now have the ability to have seeds. What we need to do now is have the ability to have a string of scenes which you can move through. Now the problem is, in the previous versions of this, I created winning and losing threads. So you could win a scene and then you could move down to the next scene in the win column, or you could lose a scene and you move down to the next scene in the lose column if one existed. But I've been thinking about what I actually want to do, and I think that what it might be better to do is keep a running total of how well you did that scene, and rather than having a winning scene and a losing scene, I think the context should be responsible for choosing which context to send you to. So if we think about it, it's like just a splitting context, right? Because the way I had it, well, no, I can't do that way. I can't do that. I can have scenes give you other challenges when you fail, but you have to come back to the main scene. Otherwise, I can't tell whether you'll be in the right place to get the final setup that we need to get, which is a problem that this kind of context engine that has to all pre-bake everything has to have. The player's progress is either you're moving forward or you lose. So even if you fail a scene, you got to fail forward. Now I can give you all sorts of penalties and I can do all sorts of other stuff, but I can't give out seeds. I can't make your failure change what kind of seeds you get, because the seeds are required. They have to be the same whether you're winning or losing. So when you fail a context, when you fail a scene, rather than having two columns, I'm trying to think, do I want two columns the same way I had before? Because that was actually pretty elegant, but if I can't actually change what's happening, all I can do is make the failure scenes give you different challenges with different rewards that aren't seeds. But they've got to go back to them. I'm trying to think about the easiest way to actually code this, because if there are two concurrent sets of scenes and you flip between them depending on whether you're winning, then there has to be a way to write up those two concurrent sets of scenes. What I think I'm going to do is not do that. I think what's going to happen is, if you fail a scene, it can spin you off to a secondary challenge. And the secondary challenge, if you fail that, it can make you just lose, or it can fail you back to the main scene with a penalty or whatever else we want. But the idea is that when we're actually writing this up, we won't have to write two columns of stuff. We'll just write one column of stuff. And sometimes there will be like, subsection A, if you lose, this happens. It should be okay. I don't think it'll be an issue. We don't need to write up forking scenes. What we do need to do instead is make it so that a progression of scenes can tell what sort of constraints it needs, or it has, what kind of seeds it needs, and how far it is from the important section. Right. I think that's going to be better. I think that's going to work better. But you know what? I'm going to leave it here. I spent the whole day kind of just peddling this kind of nonsense. I'm going to go and do marching cubes. I'm going to go ahead and polish up my bio armor. I think that's got some real potential to it, and I don't think I'm going to want to do it live on camera because I got to think really hard about it. Plus, I got to go take a pee. But I will see you on Saturday if you would like, or on Wednesday if you don't like. And, short and sweet to this week. Next time, I will be careful not to drink huge bottles of water because it's hot out. Actually, I can't promise that. It'll probably be hot out again. Such is life. See ya.